Hello everyone, my name is Liam and today I've just started my first maths YouTube channel. So I started this because I really enjoy maths, I love learning about it, and my friends would like me sending them videos, so I decided I could probably post it on YouTube. So this channel, I'll just kind of be going over things that I find interesting in maths. For starters, I'll be going over calculus from first principles, so how it was developed and the steps that people took to come to how they figured out differentiation and integration. So yeah, I'll just get started. So firstly, we'll be going over differentiation, which looks at finding the gradient or the instantaneous rate of change of a function. Now this applies to all different types of functions, so you've got like linear ones, you could work out the gradient of that, but it's mainly useful for more complex like polynomials, or such as like x squared, for example. You could work out the gradient function using differentiation. Now there is like a simple, like in school you can be taught simple power rules and different tricks and stuff, but I'll just be going over where it actually came from, so like the steps that Newton and Leibniz took to figure out differentiation. So firstly, they just took a general function such as y equals f of x, or sorry, like y equals f of x. I'll just draw it on the xy plane here. Something simple like this. And what they done was they took two different points. So, for example, this, and they said, hey, look, we can draw a secant line between the two. Just a secant line being a line that cuts a curve at two or more points. And they said that's like a fairly decent approximation for. So say we're trying to work out the gradient at this point here. They said, hey, that's like a fairly decent approximation. Obviously, it's not perfect, but we can work from that. So they took the corresponding x values. Oh, sorry, I should have labeled this as y equals f of x. This one being x, and then they said this point here is called x plus h. I don't know why they chose h, but it works for, you could choose any variable, a, b, c, or whatever. And they took the corresponding y values. So because this function is y equals f of x, then this y value here is going to be f of x. And then this y value here is going to be f of x plus h. And this distance in between here, I think it'll be handy for later on to label it as h. I'm a bit sick right now. So they just worked out from this the gradient of that secant line. Now the gradient being the change in the y values over the change in the x values. And that will be f of x plus h minus f of x divided by x plus h minus x. And that's just equal to f of x plus h minus f of x over h, because the x's cancel out. So obviously that's like not a perfect approximation for the gradient at this point here. But what they thought was, if we make this h value here infinitely small, so say we got it to be a little bit smaller. So for example, say they took this point here, that secant line there is a bit of a closer approximation to the gradient. And then they said, hey, if we made it even smaller, say here, that's really good. And that just means that the h value is getting really, really, really small. Now, obviously, you can't have it being at that exact point because the change in x values is 0, and then you'd be dividing by 0. But what you could do is you could analyze what happens to the gradient function as h approaches 0. Now, what they both done was they introduced this thing called a limit as h tends to 0. So limit as h tends to 0 of f of x plus h minus f of x divided by h. And that there is how they find the instantaneous rate of change of the gradient at that point. Now what they kind of imagined was, say, a curve such as this is little tiny lines, infinitely many tiny lines, and you can imagine it being, you can work out the gradient of those lines. And that's what the derivative is. That is the definition of a derivative, this right here. And that there is how they worked out the gradient using first principles. So that is basically where it comes from. And whenever you're working out, like, say you just find the derivative of f of x equals x squared, obviously you know to just bring the 2 down and subtract 1 from the power, that gets you 2x. And what you're actually doing is this just really shortened, because you can plug in your x squared into this here, and then evaluate what happens as h approaches 0. And in some of my other videos I'll start showing like simple polynomials using this definition here where the derivative comes from. I'll also be looking at sine of x, cosine of x, e of x, and the natural logarithm of x, maybe some other ones as well, but that is the derivative definition from first principles. So thanks for watching, hope you enjoyed.